And the main issue in data science is to optimize a function. It's basically all data science or machine learning problems is basically a function optimization. So what does it mean, a function optimization? Usually when you have a function, you want to optimize, for example, you want to find the minimum value or the maximum value. Okay? So this is basically the optimization that we talk about, yes. It's usually we use derivative. For example, imagine that you want to find the maximum or the minimum value of a function. And this usually corresponds, for example, if I want to find this minimum, this corresponds to what? A derivative equal to 0. Okay? So it will be flat. Okay, flat derivative. Okay, so this is on one-dimensional. We usually calculate the derivative to optimize the function to find the minimum value. Imagine that you have a function that represents the error. So what you would like to do with the error? You want to minimize the error. Yes. So you want the error to be almost 0. So imagine that this error will be kind of complex function, and you want to find the lowest point into that function. Now, this is in two-dimensional, everything, everybody understands, but usually when you do machine learning, we will have multi-dimensional. This is three-dimensional only, but it can be dimension of thousands. Okay, it's something that we cannot imagine because we can only print in 3D. And the objective is the same. You know, when you do derivative in two-dimensional space, we call it gradient in multi-dimensional space. Okay, and this is why we call it gradient descent. It's basically you want to calculate the gradient that will descend over a certain slope, like this. And this is just a generalization of this two-dimensional curve. Okay, but usually, and what we are going to represent as a function is basically a loss, or what we call, in more general terms, the objective function. It can be a loss, it can be a reward, okay? And it should be minimized so that we can have a best fit, okay, of the model with respect to the data that you would like to predict. When we reduce the error, it means that your function is able to convert the input features into a correct output. This is what we do. This is prediction. Okay, you have an input feature. For example, you want to classify an email whether it is a spam or not a spam. We're going to create a function, J, for example. You provide an email, it gives you an output, okay, spam or not spam. And you want to minimize a certain loss function. Of course, the design of the loss function or the error function is very important because you're going to apply gradient, okay, in many iterations so that you will reduce the error on the data that you will be using it to build your model. Okay, so the objective, as already mentioned, is to identify the optimal model, and the optimal model is the one that minimizes the error between the predicted values and the actual values. And this is what we do in supervised learning. In supervised learning, we have input known, the real output is known, and you want to make a mapping between these two through a function so that the function will produce something very similar to the actual output that minimize the error between both. And the technique used, as already mentioned, is the derivative, which we call gradient. So we call that a gradient descent. And it has a lot of applications like maximizing the recommendation system effectiveness, okay, and enhancing the weather forecast. I want to make, for example, what will be the weather after a couple of days with minimum error, or detecting whether an email is spam or not spam, and so on. These are typical examples of machine learning models.